Okay, arcs and central angles. Here's the worksheet that you have to do. I'm going to go through some examples of each type of exercise on here. But let me start by going to the back. If you can't read my handwriting, find the measure of this angle here. It's 180 minus 135 because here's the diameter. The diameter cuts a circle in half. A whole circle is 360 degrees. So half of a circle is 180 degrees. You know this part of it's 135. 135 plus something equals 180. So 180 minus 135 will give you the measure of this angle. In this picture as well, you have these two vertical angles. Vertical angles are congruent. That's why I have 180 minus 35 written in both of them. They both have the same measure. Over here on this side, the whole thing equals 360. If you add all the parts together, you get 360. Here's the two missing parts. And these little marks right here mean that these two parts have the same measure. So you can give them both the same unknown symbol, x. This is x, and this is x. Now you can add all the parts together to get 360. Over here, this part and this part both have the same measure. Now look what happens when you put these two together. They become the same as this big one right over here. That's a hint. This is 40 degrees. It's not 48, it's 40 degrees. I just didn't write that very well. How do I know it's 40 degrees? Because this 140 degree sector plus this one have to add up to equal 180 because there's a diameter right here. Down here, looky here, vertical angles. This part and this part are the same. These two put together are the same as this big one right here. Alright, so just pointing out a couple of things on your worksheet. Arcs and central angles. Okay. An arc is a portion of a circle. So if we start right here and we go around and we stop right here, we have created an arc. Arcs are commonly designated by central angles, telling us where to start, where to stop. A central angle is an angle whose vertex is at the center of the circle. That's why they call it central. It's made with two radiuses. Here's a radius, here's a radius. They make this angle right here. This is a central angle. This central angle creates this arc right here. Let's just put some letters with this. A, B, C. Okay. Try to follow the book, follow the worksheet that you're working on, and it looks as though the worksheet that you're working on always goes in a clockwise manner. Clockwise. All right, so working in a clockwise manner. This central angle creates this arc right here. It starts here, it stops here. So it's going to be called arc CA. Here's the symbol for arc. This is arc CA. Now there are actually two arcs that are created when you put a central angle into a circle. There's the one that's limited by the angle itself. Start here, stop there, by going in a clockwise rotation. This one is called the minor arc because it's the smaller of the two arcs that are made. The other arc that is made is the one that starts here at A and goes all the way around to C on the outside of the angle. You can think of it that way. It goes from A to C again in a clockwise manner. So arc AC would be called the major arc. Major arc is always the longer one, the bigger one, however you want to say it. Minor arc, CA. Major arc, AC. So in some of the exercises, you're going to have to name the central angle. The central angle in this picture, the central angle is angle ABC. Just go in alphabetical order. CBA would have been the same thing. The B is at the vertex, so the B needs to be in the center of your naming the angle. And sometimes you'll have an angle, and it will say angle ABC, so A, B, C, and it wants you to name the arc made by angle ABC. Now, think again, clockwise rotation. So what is the name of the arc made by angle ABC? What they want is just the minor arc, and it's arc CB, because you're going in a clockwise motion, C to B. That designates from here to here on the edge of the circle. Right. So name the angle, name the arc. If an angle is given, name the arc that it makes. If an arc is given, name the central angle that it makes. Sometimes they can use numbers instead of letters. Here's angle 1. We need another letter out here. Call this D. So name the arc made by angle 1, clockwise. Start at D, end at C, so it's arc DC. If you had to name the angle that arc DC made, it would be angle 1. Arc DC creates angle 1, or angle DBC, either way. Well, there's an interesting coincidence, if you will, actually not a coincidence, a correspondence between central angles and arcs. If you have a central angle that measures 89 degrees, then the arc, the minor arc that it created, also equals 89 degrees. Isn't that neat? 89 degrees, 89 degrees. Sometimes you have to add together parts to get the answer that they want you to give them. For example, if angle 1 equaled 80 degrees and angle ABC equaled 70 degrees, If the question was, what is the measure of arc DA? So starting at D, going clockwise to A, what is the measure? Well, you get that by adding the measure of arc DC to the measure of arc CA. DC, that arc is also 80 degrees because that's how much its central angle is. Arc CA is 70 degrees because that's what the measure of its central angle is. So what is the measure of arc DA? Arc DA equals arc DC plus arc CA. Now replace these with values. 80 plus 70. So it's 150 degrees. So if they give you the measure of an arc, its central angle has the same measure. If they give you the measure of a central angle, the arc has the same measure. If they give you two angles and you need the measure of the arc made by adding together the two angles or the two arcs, add the two measures together and vice versa. All right. Here we go. 50 degrees for this angle. What is the measure of this one? All right, here's the geometry. Doing things in a logical manner. All right, there's a couple of things that I know about this picture. One, I have a diameter here. So this whole conglomeration equals 180 because 180 is half a circle. Now I see these marks right here. This means that it has the same measure as that. So this part here is also 50 degrees. I'm going to call this piece that I don't know X. So 180 equals X plus 50 plus 50. Let's solve this for X. So 180 equals X plus 100. I added those two together. Now subtract 100, subtract 100, X equals 80. What is the measure of this angle? 80 degrees. What's the measure of this arc? 80 degrees. What if I had to find the distance from Y to Z? 50 plus 80, 130 degrees. They're not super difficult, but you do have to think about them so that you can carry out the geometry part, that is logical order, logical sequencing. Here's another example. Maybe I need to find the distance from A to B, the arc length from A to B. So I would start here A, go all the way around here to B. That's actually a bad example because that's 180 degrees. But let's pretend like we didn't know that. And this is what I have to work with. Well, there's a couple of things that I notice here. I notice that these two angles are marked as the same. So this one is also 4x plus 5. And then I have these two angles here, they are vertical angles, so they have the same measure. I'm going to put 2 loops in there. Okay, so these two added together plus that equals 180. I know that because this is a diameter. Well, looky here. This 1 plus this equals 180. I know that because this is still a diameter. That means that these two put together have the same measure as this whole one right here. That's the geometry part. So 7x plus 15 equals 4x plus 5 plus 4x plus 5. Adding these two together gives me the same measure as this one right here. That's what we're doing here. So simplify a little bit. 7x plus 15 equals 8x plus 10. Add the x's together, add the 5's together. Now we're ready to solve. Move all the x's to the same side. Here's the most x's, so move these over here. Minus 7x, minus 7x. Takes care of that. 15 equals 8x, take away 7x is just x, plus 10. Move everything else to the other side, so minus 10, minus 10. 15, take away 10 is 5. That cancels out. All we have here is x, so x equals 5. How does that help me? Well, now that I know that x equals 5, this measure becomes 7 times 5 plus 15. 7 times 5 is 35 plus 15, which equals 50 degrees. That's not really 50 degrees, but for this example it is. All right. Same thing here. 4 times 5 is 20 plus 5, so this equals 25. And this equals 25. So how big does this angle or this arc need to be? If this part is 50, then this is 130. It doesn't look that way. That's because of the way that I drew it. But that's how you would solve a problem such as this. Okay, try it. Pay attention to what the problem is asking you for. Major arcs, minor arcs. If this were C right here, this would be minor arc CB. This would be major arc BC, using the same letters and going clockwise. I really don't think there's anything else that I need to go over with you. You can do this. Once again, if you get stuck, give me a call, send me a message. If you text me at my phone number, I'll probably get it right away. If you email me, email the Gmail account. Try that first. That I have on my phones, and it's always with me. The other email, I have to check on a computer, and it lags a little bit. So if you need to get hold of me right away, try sending me a text message or emailing my Gmail account, or call me at that number, and I'll get back to you as soon as I can. Thanks. Bye.